Hey everybody, it's Will Strickland. I'm the Northwest Region Poultry Extension Agent for the LSU Ag Center, and today we're here at the Hill Farm Research Station to talk a little bit about poultry house tightness. We'll get into what exactly that means, why it matters, and not just how we can test on our farms the level of poultry house tightness, but what it really means when we perform those house tightness tests. So what does poultry house tightness mean? Well, poultry house tightness is really in reference to how much air is coming through leaks, holes, cracks, any place other than our inlets that we want the air to come through, those sidewall or tunnel inlets. Examples of common places that you see these leaks, holes, cracks, things like that can be tunnel fan shutters, our personal like man-sized doors, these big end wall doors, stem wall seals, the areas around our sidewall inlets may not be sealing properly, and even our tunnel doors and curtains are all common places that we see air enter our houses as opposed to our inlets. To demonstrate how this air is entering, we're going to use a handy little smoke generator and smoke this exterior door. Let's go see what's happening on the inside. We see all this smoke coming in through our leaky end wall door, and that's going to be air entering through this leaky end wall door every time we're running our ventilation. And that brings us to why poultry house tightness is important, right? It takes a lot of money to build these structures that we have, and we want to make sure the air is entering where we design the air to enter. That's because we want to take advantage of some of the heat that's on top of our ceiling. Most of our sidewall style inlets, they're designed to shoot the air across our ceiling before it falls to the ground. Two reasons for this: we're taking advantage of some of that hot air that's up at the ceiling to heat the air, and it takes longer for the air to hit the floor, giving us more time to heat the air. Heating that air is important because for every 20 degrees we heat that air, we're going to cut its relative humidity in half. The whole purpose of exchanging our air in our houses is that air acts as our sponge, and the drier we can get that sponge, the more water we can pull out of our house, the lower the house's internal humidity will be, as well as that usually results in better litter conditions on our floors. Additionally, we can see fuel savings when we cut down our house leakage. That's because exterior wind conditions can bring fresh air into the house even when we're not trying to ventilate. It's going to force air through those holes and cracks, and then our heaters have to run to heat that air even though we were not trying to ventilate at this time. So the more we can cut down on leakage, we're going to see fuel and energy savings as well. So how do we conduct a house tightness test? Well, first you're going to want to pick a calm day, right? Wind can affect things. Then you're going to close up all of the inlets in your house, both tunnel and sidewall. And then finally, you're going to turn on a fan. How much depends on the configuration that you have. Usually one tunnel fan's enough, but we're shooting for about 1 CFM per square foot. So we have a fan on here, our inlets are closed up, and then finally we're going to read our static pressure, and we're pulling 21 points or 0.21 inches of water column. This relationship between amount of opening and static pressure is important to understand, and that's because for a given CFM, the more opening there is, the less static pressure there is. It relates back because the velocity of the air doesn't have to be as high. There's more room, the river's bigger, it doesn't have to flow as fast. But what's important to also understand is that yes, you can take this number, but this number, it doesn't just mean how tight your house really is anymore. Just looking at your static pressure number meant a lot more when we were all building 40 by 500s. They all had 48-inch tunnel fans on them. Everything was kind of similar and the same. Now we have a lot of difference in house sizes, in fan sizes. We're not just putting 48s, we got 52s, 54s, 57s. So just that number on a house on your farm that, let's just say, has 57-inch fans versus a house on your farm that has 48-inch fans isn't going to mean the same thing, because there's a difference in the amount of CFM that single fan is pulling. Yeah, there are equations that you can go through and you can back calculate given the CFM and look up the, the fan test and everything. But the colleagues over at the University of Georgia have made a nice little app on their cell phone. Under the Poultry 411 app, it has a calculator on it. And it has a house leakage calculator where you can put in your house size, the fan that you used, and the static pressure that you recorded. And then it's going to tell you, your total area of leakage in square foot, but it's also going to give it to you relative in per 1,000 square foot of floor space basis. So how many square feet of leakage do you have per 1,000 square feet of floor space? And that makes everything much more relative. Then it becomes a lot easier to compare a 40 by 500 foot house with a 48-inch tunnel fan to a 66 by 600 foot house that has a 57-inch fan. This kind of relative leakage area, or square foot of leakage per 1,000 square foot, makes it to where we can compare houses of different sizes and configurations. I hope you found this video on poultry house tightness informative, and please reach out if you have any questions.